Hey everyone, welcome back to Anu's Chem Corner. I am Anu and today we are diving into the another part of MCQ series that will help you a lot in AP Chemistry exam. So even if you're feeling confident these portions like questions can really tricky, right? Let's break them together and get you fully prepared for the exam. Grab your pen and don't forget to hit the like and share and of course subscribe for more in the series. Let's get started. You can read the question and pause the video. You can find the answer and then you can check whether my answer. Okay. So first question, CO2 plus concentration is given and absorbance is given. Okay. And absorbance of CO2 plus, okay, they were given. And what is the molar absorptivity value for CO2 plus under the given condition if a cuvette with 1 centimeter path length was used? Okay, so it's actually Beer-Lambert's law, right? Absorbance. So direct equation, direct application. What is Beer-Lambert's law? If you are not aware, yeah, they will give the like equation sheets are there. So no issue. Beer-Lambert's law is absorbance is equal to epsilon BC. Correct? Epsilon means molar absorptivity. Then B means path length. We are taking some cuvette. So that cuvette have a like width like this. Correct? So here we are taking the solution. So how much distance the light is passing through the solution. That is what you mean by path length. So just this diameter of this cuvette. Correct? Okay. Not diameter. It's not cylindrical. Anyway. So that length is what we called path length. They were given it's 1 centimeter and concentration. You can take any of the concentration. They are given several concentration. So we can take the first one like 0.025. 0.025 is the concentration and the corresponding absorbance. So you have to take the corresponding absorbance like 0.13. Okay. So what should be the epsilon? Just calculation 0.13 over 0.025. Isn't it? So that will be the value of epsilon. So molar absorptivity. So I think you can get option C. Okay. Then the next one, which of the following is following correctly pairs the reaction showing the electron affinity. Very important. Electron affinity for an aluminum atom. So what do you mean by electron affinity? Electron affinity means what is ionization energy? Ionization energy means they were releasing some like they were removing one electron, right? How much energy is needed for removing an electron? So aluminum becomes Al plus by release of one electron. So how much energy you have to put for this reaction to occur? That is what we call the ionization energy. Okay. So if it's so, what is electron affinity? Electron affinity is just opposite of ionization energy. How much energy they released when an electron is added to the valence orbital. Okay. Ionization energy is endo energetic. You have to put energy. It should be positive. But electron affinity means always release of energy. When one electron is added to the aluminum, so what's the species? It becomes negative. Correct? That energy, how much energy is released during this reaction, that is what we called electron affinity. So the answer will be first option. Okay. Then second one, next question, use the following information to answer the question 13 to 16. So 13 to 16, these are the data provided. Okay. Let's see, a 0.1 molar solution of NaOH, 0.1 molar NaOH is there, is titrated into 20 ml of H2C2O4 diprotic acid, okay, of unknown concentration. The pH of H2C2O4 solution is monitored as the NaOH is added to it, resulting below the graph. Okay, so this is the curve. First question, what is the concentration of H2C2O4 solution? How to do it? Yes, if you have the like titration curve, you can simply use, if you know the endpoint, you can simply use the equation M1V1 is equal to M2V2. Can we? No, isn't it? Can we use that one? This equation we can use only when if it's a monoprotic acid and base. Correct? Monoprotic acid as well as monobasic base. Okay, if it's so only we can use M1V1 is equal to M2V2. Otherwise, you need to consider the stoichiometry. So simply you can rewrite the equation like number of H plus M1V1 is equal to M2V2 times number of OH minus. Okay, so what do you mean by number of H plus? See, they were telling it's diprotic acid. Okay, so do not blindly believe like this number is always meant to diprotic and triprotic like that. For example, acetic acid C2, H3, O2, and H. So this is acetic acid, correct? So even though this is acetic acid, which doesn't mean it's a tetraprotic acid. No, they can only give one H plus. So it's again monoprotic acid. Okay. So do not blindly believe this number. So they will give the data. Is it monoprotic or diprotic like that? They will give. So otherwise you may be not familiar. Okay. So H2C2O4 is again it's a diprotic acid they were given. Since it's diprotic, you can directly write 2. Number of H plus is what? 2. Then molarity is what? That's we need, right? Volume of H2C2O4, do you remember? 20 ml like that they were given in the question. And molarity of NaOH, what was they were given? 0.1, correct? And the NaOH volume is also, what is the NaOH volume? This is 0.1, and see NaOH ml, you can take it from the graph. So which is the end point? Is that this one is the end point? Here, what is this one? It's a first equivalent point and the second one is second equivalent point. Okay. So the reaction is complete at second equivalent point. So you can take the 20 ml. Okay. So that will be the and number of OH minus is 1. Correct. Just 1 only. So what is the molarity? You can take 0.1 times 20 over, yes, 20, and again some 2 is there. Okay, that extra 2 is there, so that you can get 0.050. Okay, so that's the thing. So why there is 2 endpoint? You have any doubt with why there is 2 endpoint? Because it's diprotic acid, isn't it? So that's why there is a 2 endpoint. Okay. The next one. At the point at which 20 ml of NaOH has been added, which of the following species is present in the greatest concentration solution? Which is a very good question. So see, this is our pH curve. We know that at equivalent point, who determined the pH? We study that one, right? If you have any doubt about the titration, you can just check my videos of titration. You can see the link in description. Okay. So see here the end point salt will determine the pH. That's we studied. Okay. So here is the end point. So which is the salt? What is our equation? H2C2O4 plus NaOH is the reaction, isn't it? So by doing so, what's the product? What are the product? Diprotic acid do not like it's not a considered reaction. It's a two-step reaction. So first H2C2O4 will release one H plus. So the remaining species is HC2O4. Okay. Then that HC2O4 minus will react with the remaining NaOH. So they will release like C2O4 2 minus. Correct? Got the idea? So first H2C2O4 NaOH will react. What happened? In first step they will give 1 H plus. 1 H plus they will donate. Okay. So the remainder species is what? H plus. And what is the remainder species? HC2. Oh, you may not see this one. You can be. Okay. So H2C2O4 plus NaOH. First they will react with the first H plus. So that the remainder species is H plus and HC2O4 minus and Na plus will be there. Okay, so this is minus, this is plus. Like that will be the first, this is the first salt. Okay, so at first equivalent point, this will be the highest in number like HC2O4 minus Na plus. Okay, Na plus you can write it just like a spectator ion. Even if you are not right, no issue. Okay, then what happened in second phase? What happened? This HC2O4 minus Na plus will react with another NaOH and forming another H plus, and they will donate C2O4 2 minus. So you can write Na and this one is 2. Sorry, Na2. This one is 2. Correct? Sodium is 2 in number. So sodium is not mandatory, like C2O4 2 minus, or Na2C2O4. This will be our second salt. Okay, so here at this end point, the most common species is Na2C2O4. Correct? Okay, so you can choose that one. So see the question options. You can see C2O4 2 minus. As I told you, Na you can omit. No issue. Na is just like a spectrate ion, not an issue. Okay, so since it's second equivalent point, that will be the salt. Okay, then next question. Phenolphthalein is an acid-base indicator with a pK of 9.1. Okay, its protonated form is often abbreviated as HIN, while its conjugate base is abbreviated as IN minus. Okay, at the following volume of NaOH added, select the option that accurately describe which form of the indicator will be present in greater concentration. Okay, so the question is, at 5 ml of NaOH, indicators which form is like dominant. At 15 ml of NaOH, which is dominant. Indicator thing, we are talking about indicator. Okay, so indicator means pH is equal to, you can think about like pKa plus or minus 1. Okay, so pK is 9.1, which means plus or minus 1. So what is the range? 9.1 less than minus 1 means 8.1 and 10.1. So below 8.1, their acid form will be predominant. Above 10.1 pH, okay, we are talking about pH. pH above 10.1, their base form will be the predominant form. So that's a acid base indicator concept. Okay, indicator means pH is equal to, you can consider pH is equal to pKa plus or minus 1. So what is that shows a range. So pK given is 9.1. So 9.1 plus or minus 1, which means the range should be 8.1 to 10.1. The meaning is below 8.1, acid form will be the predominant. Above 10.1, base will be the predominant. So let's see 5 ml, 15 ml, which is, what is the pH of 5 ml? See, look at the graph. 5 ml of adding NaOH, 15 ml of adding NaOH. You see, the value is below 8.1. pH is below 8.1, isn't it? See the pH at this one, at 15 ml. See, it's very clear, it's less than 8.1, which means acid form will dominate. And what about 25 ml? See the 25 ml. 25 ml, you can see the pH at something around 13, 14 something, correct? See, it is actually greater than 10.1. So that's why you can take, it's a base form. Base form will be predominant. So first two thing, acid form will be predominant. So which is option? Acid form means HIN. Acid form means HIN. Clear? So below 8.1, acid form will be predominant. Above 10.1, base form will be predominant. So IN minus. Okay, so you can go with option A. Okay, then next one. If the H2C2O4 were to be replaced with the identical volume of H2SO4, what volume of NaOH would be required to fully neutralize the acid? See, very, very important. Every time they were asking this question. Okay, what happens when a weak acid is replaced by a strong acid? Is there any change in the equivalence points? That's the question, isn't it? H2C2O4 is a weak acid. At the same time, H2SO4, it's a diprotic acid but strong acid. So is there any change by weak acid replaced by a strong acid? Is there any change in NaOH volume? The answer is no, because the number of moles they were offering is same, isn't it? The number of moles are same, so that there is no change in the volume of NaOH used. So if the other one is 20, then this one also should be 20. Okay, that's it. The next question is, 2Ag plus Fe gives Fe2 plus 2Ag. Reaction is given and E0 cell is given. Okay. The above reaction taking place in a galvanic cell and has a standard reduction potential 1.24 voltage at 25 degrees Celsius. Okay. Which of the following would decrease voltage of the cell? Okay. Doubling the mass of Fe, adding catalyst, increasing concentration of Ag plus adding water. So you have to understand that E0 we need to decrease. So decrease means, see, due to this reaction, energy like E cell is producing. Okay. So if forward reaction is it happening, like if more like the stress is it lead to a forward reaction, then more will be the E cell. If backward reaction is happening, then our E cell will be lower. Okay, so that's the principle. So here we need to decrease that one. So the condition is we need a E cell lower than E0 cell. Okay, for that we need to think about which stress is leading to a backward reaction. Correct. So let's see. First one, doubling the mass of Fe is solid. See, it's solid, so not affecting. Correct. Okay. Adding catalyst also they were not changing like equilibrium, isn't it? Okay. Then increasing concentration of Ag plus. See, Ag plus is the reactant side. So if you are increasing Ag plus, again forward reaction is happening, so that you can get a higher E cell than E0 cell. Adding water, what about water? Adding water is always it's a standard result. Make sure so many questions related to this water equilibrium, it's a very very important. Adding water is always lead the reaction in which more number of moles produced. Okay, adding water will leads to more number of moles producing. So which side is more number of moles producing? See here 2 plus 1, here 2 plus 1, is it 3 3? So both of them 3? No, no. Why? See, we not need to consider the solid phase. So how many moles are there? In the reactant side 2, and in the product side there is only 1 mole. Okay, so adding water will lead to increase the number of moles. So which side is increasing the number of moles? Yes, backward reaction. So this leads to a backward reaction. So that's our answer. Okay, because we need decrease backward reaction. Clear? Okay. Next question, they were given an uncatalyzed reaction and this is the velocity distribution for this reaction. Okay. This reaction is governed. Okay, then what's the question? A sample of H2O2 is present in a flask. As time passes, the molecules may collide to form the indicated product. The shaded area under the graph represent the number of effective collision which create products under standard condition. Okay, so this area is indicating the number of the number of effective collisions. Okay, so given the distribution, given the energy distribution curve for the uncatalyzed reaction, okay, which curve would best represent the catalyzed reaction? So this is uncatalyzed. Okay, they were given, and what we need is catalyzed. So what happened when you are catalyzed reaction? What happened? See the curve. You can check the answer. Like you can tell the answer. During a catalyzed reaction, there will be, yes, the rate is increased. Why? There are more collisions. Now there are more collisions. So you have to check with the more area. See the area of the first one, and you have to choose the answer with a higher area of like area of shader area. You have to choose. Correct? So which one? Yes, this one you can choose. Correct? So that one, not B, right? Yes, so that's the more area thing. So that will be the answer. Okay, that's all. Then the next one, 2CO plus 2NO gives 2CO2 plus N2. CO at a, so that's a reaction. Okay. CO at a partial pressure of 2 atmospheres. So we can write 2CO plus 2NO gives 2CO2 plus N2. Okay, so before reaction, what's the thing? Before reaction, first one initially it's 2 atmosphere of CO, okay, and NO at a partial pressure of 1 atmosphere, okay, mixed in an evacuated and sealed container where they react via the above equation. What's the total pressure of all gas present in the flask after the reaction goes to completion? Okay, just no, normal stoichiometry only. We need to write after reaction. After reaction, what happened? What are the moles? Which is the limiting reagent? See the ratio 2 require 2, but there is only 1, which means who's the limiting reagent? Yes, NO is the limiting reagent. Correct? So the reaction is not in an equilibrium, so don't want to consider the ice table. So just before reaction, after reaction is sufficient. Why? Because they were telling it's goes to the completion. Okay, so NO you can consider the limiting reagent. So after the reaction, NO will be 0. So what is the CO? CO will be then, initially it is 2 zeros are there. 2 is to 2 ratio. So 1 NO need 1 CO. So after reaction, there will be 1 CO left. Isn't it? 1 CO is consumed and 1 NO is consumed. So that, see the ratio, 2 NO gives 2 CO2, which means 1 NO gives 1 CO2 and 2 gives 1 N2. So 1 gives half N2. Correct? Normal, just stoichiometry only. We are considering just like a normal stoichiometry. Like even it's a pressure, you can consider just like a concentration term. If in case of gas, we are usually used pressure instead of concentration. So what's the left thing? See, after the reaction, you can see 1 CO and 2 CO, sorry, 1 CO2 and half N2, which means 1 plus 1 plus half, so 2.5. So 2.5 atmosphere will be the thing. After reaction, 2.5. Okay, right. Then, see, there is a PS, like potential photoelectric spectrum is given, PS of oxygen. Correct? Photoelectron spectrum for an oxygen atom is shown above. Which of the diagram below would be the correct spectrum for the oxide ion? What we need is oxide. O2 minus is needed. What is given is oxygen. So what is this photoelectronic spectrum? Nothing, our normal configuration, right? So 1s2, 2s2, what is electron? 2p4, correct? 2 4 2 6 and 8, so 8 electrons are there. So this is the electronic configuration. So you know the height is representing the number of electron. 1s2, 2s2, same number of electron, that's why same height. 2p4 is exactly double, correct? So O2 minus is nothing but extra 2 electron is added. Is it can be accommodated in 2p? Definitely 2p have maximum 6 electron. They can accommodate maximum of 6 electron. So what may be the diagram? Ah, first one, isn't it? This is 1s2, this is 2s2, and this is 2p6. Okay, so that's all right, that's all about today's video. If you have any doubt, please drop a comment below. And yeah, definitely, if you found this video helpful, please do like and share and support, and don't forget to subscribe to Sanu's Chem Corner. Bye, thanks for watching.